Hey guys, how's it going? So we continue with our paper. Okay, so I have a student joining, Monash.
Hello guys.
So we'll be going through the questions. The both of us, you'll be asking some questions as well as contributing. Okay, so question 6.
Feel free to the comment section.
You're crazy. So question 6, it says if the bearing of P from Q is 0.054, find the bearing of Q from P. Okay, so how do you think we should work this out?
I don't know actually.
okay, that's fine. Yeah. So when you're going to give you bearing, there are some words which I call buzzwords. So buzzwords, so for example, they can tell you from. So from is where you put a cardinal point. So bearing, normally you have to be, the bearing would be taken from the north. Okay, so bearing would be this angle here, taken from the north. Okay. So when they say from, it means that you're starting with that point normally. So here would be, you can say this one is your point, and then you can say this one is your Q. Okay, so it says from Q, so you can put a cardinal north here. So you're told that the bearing of P from Q, so here 5054 054, it means less than 90, so you can put it in this, we call it a quadrant, so you can put it in here. Okay, so this one would be 90, but then you can put it somewhere in here. Okay, so it's just a sketch, so you can say this one, and then maybe you can say that your P is here. Okay, so here this angle here would be 54. So the trick is the trick is that if they say from Q, if you want to do a sketch, just start with the point Q, and then now derive the bearing. So the bearing would be this 54 degrees here. So it says find the bearing of Q from P. Now they're saying from P. So we should write the cardinal north where? On P. Exactly. So you can write the north part would be here. Okay, so this one would be your new north, and then the bearing would be this angle here. Okay, so this is the angle that you're looking for.
Okay.
So now you're dealing with angles.
Okay.
Yeah. So this one is parallel to this one, right? These are parallel. The north.
Oh, the norths are parallel.
Yeah. So this one is going up. This one is going up as well, and then they are parallel. So if they are parallel, the angles that are in here, they're called allied angles.
Okay.
So they're called allied just because they help each other. They're allies. They help each other to get you 180. Okay, so that's why they're called allies. Exactly. So they're allied angles. So you can find this angle here. Okay, so how would you find this angle here? You'd say 180 minus 54. Since they help each other to get to 180. So 180 minus 54 here, you get 6. Here you get 6 here, then you get 2. You get 126. Okay, so this one would be 126. If you're really fast, some of these math you can actually work them by head, and this is how you do it. So 180 minus it was what? It was 54, right?
Yeah.
You can say it simply as 180 minus 60 plus 6. Okay. So how do I know? Just because minus 60 plus 6 it's equal to negative 54. But then in your head you can process minus 180 minus 60, because 180 minus 60 it's simply 120. Then you add 6, so you get 126. So if you want to use your head, you can also do, but then here it's also safe. Okay. So after getting 126, this angle here we can get, right?
Yes.
We can get how do
we subtract it
from
180?
It would be 360 this time. So the reason we are subtracting from 360 is that a point is a revolution. Okay. It has 360 degrees. Okay. So it'd be this whole angle here. It'd be minus 126. You can also use the more or less the same method that I used here, but then we're going to do strictly the longer method. Okay, so you should 3 here, then here you get 3, right? Here you get 2, so you get 234, right?
Yes.
So 234. Yeah, are you happy? Is this fine? It's fine, right?
Yeah, it's fine.
Okay. So the second part, it asks us to calculate the number of sides of a regular polygon with interior angles of 126 degrees each. Okay. So here buzzword, or you still remember here we had this from, and then we said from it's an important word, right?
Yes.
Here we also have an important word. The important word is regular. Regular, what do you think regular means?
Normal.
It might mean normal, but then in this context here, when they say regular in maths, they mean a regular polygon. In maths, they mean that all the sides, they're the same.
Oh, okay.
That means all the angles also they are the same. Okay, so this is an important point important information to how we were going to work this out. Okay, so this one, regular polygon, simply means all the sides they're equal.
Okay.
Yeah, and then they say that the interior angle is 162 degrees each. Okay, so one interior angle is equal to 162 degrees. The sum of interior angles, you should know the formula. So the sum of interior angles, you should know the formula. The formula is 180 n minus 2. Okay, so if you forget the formula, just think of you can write whatever you write, but then use a triangle. Triangle has 3 n equal to 3 sides. So it'd be 3 minus 1, then you get 1, right? Then you say up times 180, then you get 180. The interior angles of a triangle, they're equal to 180.
Okay.
Yeah, so that's how you verify. So here, this one would be for n, whatever number, it follows this formula here. So you expect it to recall this formula from memory.
Okay.
Yeah. So here, it's equal to what? It's equal to, this one would be the sum of the interior angles. But then you have one interior angle, and then the angles, they are the same. So the total number of interior angles would be one interior angle multiplied by what? By the number of sides.
Oh, okay.
You get it?
Yes.
Yes, because you have the interior angles, they are the same, and then you have number of sides. Number of sides is equal to number of angles. So you can just multiply. So it'd be 162 here by n, which is the number of sides.
Yes.
Okay, so you have this formula, it gives you the total, and then this formula, it gives you the total as well. So now you want to evaluate n. So you can expand out, right? So you get 180n minus 360, right?
Yes.
Is equal to 162n. So here, which one should you put? Should I put this one there or this one there?
No, you should put 180. 180 should go
To the side.
162, yes.
Yeah, so it's also okay. You can find the correct answer if you do that. But then you want to, if this one is smaller, it has to visit the bigger one.
Oh.
Yeah, because this one is positive, this one is positive. So this one is smaller, it has to visit the bigger one. If it visits the bigger one, that means you won't have to deal with negative numbers, okay?
Okay.
Yeah, so if you don't deal with negative numbers, it's an advantage for you. If you take this one, you would have to say 162 minus 180. So it's kind of tricky. So here you say 180 minus 162. You say 180 minus 160 first. Then you say you get 20. Then minus 2. Then you get 18. Okay, so that's how you do it. So you get 18 and this is paper 1. Okay, so you're not expected to use a calculator. You're expected to do everything from memory or just by working it out. Okay, so you have 18n equal to 360. So 360, to get n, we divide by
18.
By 18, exactly. So by 18 here, then we say 18 into 18 into 36, then you get 2 into 0, then you get 0. Okay, so here you get n equal to what? 20. Okay, so number of sides equal to 20. So that's how you go about doing it. Okay, so just to recap, what you do is you have to recall the formula for the total number of sides. You should recall it from memory. Okay. And then we said we can verify it by using a triangle which is 3. Okay, so it's equal to the one interior angle multiplied by the number of angles, since the interior angles, they are the same for a regular polygon. Okay, if it's irregular polygon, you have to deal with something different, but then here it's for a regular polygon, so that's why we are. So question 7 it says express 1 over x squared minus 1 minus 1 over 1 plus x. Okay, you're asked to express it as a single fraction in its simplest form. Okay, so how do you think we should go about working this out or not?
I think we should take down the denominators first.
Okay, so you're looking for the common denominator, right?
Yes.
Yeah. So the common denominator, how would you find it?
In this case, I would take x squared minus 1.
Mhm.
But
Why?
Because 1 plus x can get into x squared
Minus 1.
1. Yeah.
Exactly. So that's really good. And then as a first step, so here you were saying that this one you should take it as a common denominator, because 1 plus x is also a factor to x squared minus
Yes.
1. So the way that you do it is you should always, whenever you're confronted with this one, we call it an algebraic expression. So if in an algebraic expression, whenever you're confronted with that as a denominator, you should always factorize it first.
Okay.
Okay, so if you factorize it, factoring means to expose the factors. Okay, so to expose the factors means to factorize. Okay, so here you get 1 over, so you get x plus 1, x minus 1. What is this called?
Factorization.
Yeah, but then this kind of quadratic expression, what is it called? It's called difference of two squares. Okay, so this one is a square, 1 is also a square, and you have subtract in between.
Okay.
So it's called difference of two squares. Okay, so that's how we knew that we are supposed to factorize this way: x plus 1, x minus 1, because you take the square root of the first square, and then you say plus and minus the square root of the second square. Second square is simply 1. Okay, so here minus 1 over 1 plus x, like this. So you'd actually put the common denominator now. This is the step. Okay, so here it's important for you to not skip the step here, because sometimes you'd be having negative.
Okay.
So you say all this into this, you get 1, right?
Yes.
Multiply by 1, you get 1 again. So all this into this one cancels out, and then you're left with this one, right?
Yes.
So you say minus 1.
Multiply by brackets.
Yeah. So x minus
Plus.
1. X minus 1 is left out, right? Because you have x plus 1 here,
Yes.
cancelling with this one. So the important thing here, one of the second tricky part was putting these in brackets.
Okay.
Because this negative has to be to distribute inwards. Okay, so some students, they don't put the brackets. You're supposed to put brackets. Whenever it's actually better for you to use brackets where it's unnecessary than for you to miss a bracket. If you miss a bracket, then it becomes a problem. Okay, especially where you have negative here, because this negative has to distribute inside. Okay, so you'd actually have 1, then minus x, right?
Yes.
Then here you get minus, then you get what?
Plus.
So it'll be plus 1 by x plus 1, x minus 1, just like this. So you get what eventually?
Get minus x.
Minus x plus 2, right? So you can say 2 minus x, right? So it's 1 plus 1. You're now grouping like terms. So you get 2, then 2 minus x over x plus 1, x minus 1, like this. Okay. So you happy?
Yeah, I'm happy.
Okay, great. So we're done with this part. We'll continue from the next part. Okay, so thanks so much for watching. Make sure you like, share, and subscribe. Giba out.